There is a place in the North Sea where, on certain days, when the water is calm and the light bends just right through the surface, fishermen still pull strange things from the deep. Not fish, but bones. Not shells, but spearheads carved from antler, notched with sawtooth barbs, rubbed smooth by 10,000 years of silt and current. These are not anomalies. They are dispatches from a world that once existed in plain sight, an entire landscape with rivers and forests and people, now drowned beneath 60 feet of cold gray water. We tend to think of coastlines as permanent things. The edge of the land meets the edge of the sea, and that boundary feels ancient, elemental, fixed. Maps reinforce this illusion. We draw nations as though their borders with the ocean were settled long before we arrived. But the truth, established beyond any reasonable dispute by geology, by archaeology, by the patient accumulation of evidence over a century and a half, is that coastlines are among the most temporary features on Earth. They advance and retreat on timescales both vast and, occasionally, terrifyingly abrupt. And when they advance, when the water rises, they do not merely redraw the map, they erase it. 20,000 years ago, during the peak of the last glacial period, global sea levels stood roughly 130 meters lower than they do today. That is not a marginal difference, it is a different planet. Entire continental shelves, now submerged beneath shallow seas across every inhabited continent, were exposed as dry land. Between what is now Britain and the European mainland, a vast territory stretched from the eastern coast of England to the Netherlands, Denmark, and beyond. It was not a narrow causeway or a temporary bridge. It was a landmass nearly the size of a mid-sized European country, with hills and valleys, braided rivers and wide estuaries, marshes thick with life, and coastlines of their own, facing a North Sea that did not yet exist. Archaeologists call this territory Doggerland, a name coined in 1998 by the University of Exeter's Brian E. Coles after the Dogger Bank, a submerged sandbank in the middle of the present-day North Sea, itself named for the Dutch fishing vessels called doggers that once worked its shallow waters. 20,000 years ago, during the peak of the last glacial period, global sea levels stood roughly 130 meters lower than they do today. That is not a marginal difference, it is a different planet. Entire continental shelves, now submerged beneath shallow seas across every inhabited continent, were exposed as dry land. Between what is now Britain and the European mainland, a vast territory stretched from the eastern coast of England to the Netherlands, Denmark, and beyond. It was not a narrow causeway or a temporary bridge. It was a landmass nearly the size of a mid-sized European country, with hills and valleys, braided rivers and wide estuaries, marshes thick with life, and coastlines of their own, facing a North Sea that did not yet exist. Archaeologists call this territory Doggerland, a name coined in 1998 by the University of Exeter's Brian E. Coles after the Dogger Bank, a submerged sandbank in the middle of the present-day North Sea, itself named for the Dutch fishing vessels called doggers that once worked its shallow waters. But proof of existence and understanding of that existence are separated by an enormous gulf, and for decades Doggerland remained on the margins of serious inquiry. The archaeology of the 20th century had so much dry land to excavate that looking beneath the sea seemed impractical, even quixotic. Coles changed that trajectory in 1998 with a paper titled Doggerland, a Speculative Survey, in which she reinterpreted the scattered evidence and argued, convincingly, that Doggerland was not a bridge at all, but a homeland, a place people knew, a place they lived, a heartland of Northwest European Mesolithic culture. Instead of focusing on land as bridge, she wrote, we focus on land as a place to be.
The question that followed was the obvious one. What kind of place? The answer required someone willing to pursue it underwater, without ever touching the ground. Vincent Gaffney, a landscape archaeologist who would go on to found the Submerged Landscapes Research Center at the University of Bradford, took up that pursuit with a method no one in his field had attempted before. Beginning in the early 2000s, Gaffney secured access to three-dimensional seismic survey data collected by the petroleum industry. These surveys, conducted by ships that emit sound waves toward the seabed and record the reflections, produce extraordinarily detailed cross-sections of subsurface geology. They cost tens of millions of dollars to acquire and were designed to locate crude oil deposits, not to reconstruct lost landscapes. But Gaffney recognized that the thin upper layer of seismic data, corresponding to the period when glaciers were melting, contained information of immense archaeological value. Using banks of powerful computers and stereoscopic screens, he began transforming that data into three-dimensional maps of a world no one had seen in 8,000 years.
What emerged was not a barren crossing. It was a richly textured landscape. Ancient river valleys appeared, along with estuaries, salt marshes, chalk outcrops, and gently sloping hills. Gaffney identified more than 25,000 square kilometers of terrain, revealing a territory characterized by the kind of ecological diversity that supports long-term human habitation. The land held freshwater systems, coastal resources, and varied topography. It was, by every measure that matters to foraging peoples, an excellent place to live.
Subsequent work deepened this picture dramatically. Robin Allaby, an evolutionary geneticist at the University of Warwick, has analyzed hundreds of teaspoon-sized samples from sediment cores drilled from beneath the North Sea along the path of the prehistoric Southern River, a waterway that once flowed through southern Doggerland before emptying into a wide estuary. By sequencing the ancient environmental DNA preserved in fine silts and clays, material that, because it was transported only short distances by slow-moving water, reflects the local ecosystem rather than distant upstream environments, Allaby and his colleagues have reconstructed Doggerland's biology with remarkable specificity. They identified 574 taxa of plants. They found DNA from oak, elm, hazel, willow, and alder. They recovered genetic traces of boar, deer, bear, and aurochs. In a study published in the Proceedings of the National Academy of Sciences in early 2026, they presented evidence that temperate forests existed in southern Doggerland as early as 16,000 years ago, thousands of years before such forests recolonized Britain and northwestern Europe after the final retreat of the glaciers. They even identified DNA from a walnut relative, Terracaria, that was previously thought to have vanished from the region 400,000 years ago.
This is not a marginal revision of the archaeological record. It is a fundamental reorientation. Southern Doggerland, it now appears, may have served as a glacial micro-refuge, a pocket of milder climate where temperate species survived the Ice Age and from which they later recolonized the surrounding territories. If confirmed by further research, this could help resolve what biogeographers call Reed's paradox, the long-standing puzzle of how trees like oak spread northward after the glaciers retreated, far more rapidly than their seed dispersal rates should have allowed. The answer may be that they did not need to travel from distant refugia in southern Europe at all. They were already here, in a forest that is now at the bottom of the sea.
Doggerland did not disappear all at once. Its submersion was a process that unfolded over millennia, driven by the same force that created it, the behavior of ice. As global temperatures rose following the last glacial maximum, ice sheets that had extended across much of northern Europe began to retreat. The meltwater had to go somewhere, and it went into the oceans. Sea levels climbed, not steadily, but in pulses, episodes of rapid rise punctuated by periods of relative stability. The most dramatic of these was Meltwater Pulse 1A, approximately 14,600 years ago, during which global sea levels rose by as much as 16 to 20 meters in roughly 3.5 centuries. That translates to a rate of roughly 40 to 50 millimeters per year, imperceptible in a single lifetime perhaps, but devastating across generations, and enough to transform the geography of entire continents. For the people living on Doggerland, the water's advance would have been slow enough to observe across a lifetime. Estuaries widened, salt marshes crept upstream, familiar stretches of coast disappeared beneath the tides and did not return. The DNA record from the Southern River shows exactly this pattern, a gradual encroachment of marine indicators into what had been a freshwater system. Over the course of several thousand years, the vast lowland plain shrank to an archipelago, the archipelago to a single island, the island to the shallow hump of the Dogger Bank. And then it was gone. But the submersion was not entirely gradual. Around 8,150 years ago, a catastrophic event accelerated the process. Off the coast of Norway, an enormous section of the continental shelf gave way. Known as the Storegga Slide, this submarine landslide involved an estimated 3,500 cubic kilometers of debris, a volume almost beyond comprehension, and generated a massive tsunami that swept across the North Sea. Sedimentary evidence of this wave has been found along the coasts of Scotland, Norway, and the Shetland and Faroe Islands. Recent modeling suggests the wave could have reached heights of 25 meters in some coastal areas. For what remained of Doggerland at that time, already diminished, already fragmenting, the Storegga tsunami may have been a death blow, inundating the last low-lying areas and rendering them permanently uninhabitable. Some researchers have cautioned that the tsunami's role in Doggerland's final submersion may be overstated, noting that parts of the landmass appear to have survived the event and persisted for centuries afterward. But whether the end came in a single devastating wave or through the slower, relentless accumulation of tidal incursions, the result was the same. By roughly 6,000 years ago, the last trace of Doggerland had slipped beneath the surface of the North Sea. Doggerland is the most extensively studied submerged prehistoric landscape on Earth, but it is far from the only one. Across the globe, the post-glacial rise in sea levels buried an area of formerly dry land roughly equivalent to the size of North America. The Sunda Shelf, which once connected the islands of Southeast Asia to the mainland, creating a vast lowland territory known as Sundaland, was inundated as the seas rose. Beringia, the land that once linked Siberia to Alaska and served as the pathway for the initial human colonization of the Americas, now lies beneath the Bering Strait and the Chukchi Sea. The Sahul Shelf extended Australia's coastline hundreds of kilometers to the north and west. In the Mediterranean, coastlines that were home to some of the earliest complex societies now lie submerged off the coasts of modern nations that scarcely know they are there. Some of these submerged landscapes have yielded extraordinary specific evidence. Off the southern coast of Laconia in Greece, the underwater site of Pavlopatri preserves the remains of a Bronze Age town dating back approximately 5,000 years, with intact building foundations, streets, courtyards, and burial sites still visible on the seabed. It is widely recognized as the oldest known submerged city in the world. Unlike Doggerland, Pavlopatri was not drowned by global sea level rise, but was submerged around 1000 BCE by earthquakes, a reminder that the forces that swallow coastlines are varied, including tectonic activity, volcanic subsidence, and the slow settling of deltaic sediments. Off the coast of Brittany, in France, marine archaeologists recently identified a 120-meter-long stone wall submerged 9 meters beneath the surface near Seine Island. Dating to approximately 5800 BCE, this massive structure, comprising large granite slabs, smaller stones, and upright monoliths, is the largest underwater construction ever found in France. It may have been a seawall, built by a Neolithic coastal community to defend against encroaching tides, or a sophisticated fish trap. Either interpretation speaks to a degree of social organization and engineering capacity that complicates simplistic narratives about early European coastal societies. Off the coast of Gujarat, India, underwater surveys near the city of Dwarka have revealed submerged stone structures, pottery, sculptures, and ancient anchors. Hindu texts describe Dwarka as the legendary kingdom of Krishna, said to have been swallowed by the sea. The Archaeological Survey of India has conducted multiple underwater expeditions at the site, and while the age, origin, and cultural affiliation of the submerged remains are still debated among researchers, their existence is documented. The intersection of religious tradition and physical evidence at Dwarka illustrates a broader phenomenon. Many of the world's flood myths, found in cultures separated by vast distances and centuries, may preserve collective memories of real inundation events experienced by coastal peoples as the seas rose at the end of the last ice age.
The technology for investigating these submerged worlds is advancing rapidly. High-resolution seismic surveys, sedimentary ancient DNA analysis, photogrammetry, marine magnetometry, and artificial intelligence are all being applied to the problem of reading landscapes through water, silt, and time. At the University of Bradford, researchers are training machine learning programs to sift through the enormous data sets generated by seismic and environmental surveys, identifying patterns that might indicate the presence of human-made structures, fire pits, post holes, concentrations of worked stone buried beneath the seabed. In 2019, Gaffney's team achieved a milestone. Using a mechanical grapple lowered 30 meters to the floor of the North Sea, they recovered a fragment of worked flint from the bed of the prehistoric Southern River. It was a hammerstone, a tool used in the manufacture of other stone tools, and it was the first artifact ever directly prospected from beneath the open North Sea, as opposed to being found by chance in a fishing net or washed up on a beach. It was a small object, fitting neatly in the palm of a hand, but its significance was immense. It placed people definitively in a specific location within Doggerland. It transformed the theoretical into the tangible.
There is an irony embedded in this work that Gaffney himself has noted. The seismic data that allowed him to reconstruct Doggerland was generated by the petroleum industry, the same industry whose products, burned for energy over the past 2 centuries, have driven the climate change, now causing sea levels to rise again. And the renewable energy infrastructure being built to replace fossil fuels, the vast wind farms proliferating across the North Sea, threatens to put Doggerland permanently out of reach, beneath a tangle of undersea cables, anchors, pilings, and safety exclusion zones. The window for investigating the submerged landscape, Gaffney has argued, is closing. The European Research Council recently awarded his team 13 million euros for the Subnautica project, the largest grant in the history of submerged landscape archaeology, aimed at investigating the entire South North Sea and parts of the Baltic Sea. It is a race of a kind, not against natural forces this time, but against the industrial infrastructure of our own making.
What remains beneath the waterline, then, is not merely sediment and stone and ancient DNA. It is the material record of a question that every generation of coastal humans has eventually had to confront. What do you do when the water rises? The inhabitants of Doggerland answered it by moving. Over centuries and millennia, as their homeland shrank, they migrated east and west to the higher ground that would become the modern coastlines of Britain, the Netherlands, Denmark, and Germany. They carried their tools, their knowledge, their cultural practices. They adapted. Mesolithic settlements and burial sites found along the present-day shores of the North Sea are in a sense the terminus of that long migration, the places where people stopped because there was, at last, nowhere left to go that was not already inhabited.
An estimated 190 million people today live on land that current projections suggest will be below sea level by the end of this century. The mechanisms are different. The cause now is anthropogenic, not orbital, but the physical outcome is the same. Coastlines will move. Land that is inhabited will become uninhabitable. Communities will face the same choice that Doggerland's inhabitants faced. Though in a world with 8 billion people, the calculus of migration is incomparably more complex.
Gaffney has said that the flooding of Doggerland was the last time humans experienced climate change at the scale we are now confronting. The difference is that this time, we are not merely witnesses. We are the cause, and we have, sealed beneath the water, an almost complete record of what happened the last time, if we can read it before the opportunity is lost. The past, submerged but not destroyed, still has something to say. The question is whether we are willing to listen to a landscape we can no longer see, about a future we have not yet learned to imagine.